So let's begin. Joining us are the co-authors and illustrator of Geology Underfoot in Southern California's second edition. To introduce our fellow speakers and to moderate this event, I am pleased to introduce one of the book's co-authors, Dr. Art Sylvester. A professor emeritus of geology at the University of California at Santa Barbara, Dr. Sylvester is featured as one of 190 notable earth scientists in Alexander E. Gates' book, A to Z Scientists. Welcome, Art, and thank you for joining us this evening.
Hello, everyone, and a very good evening to wherever you may be. I'm talking to you from Santa Barbara, California, and we'll be hearing also from Wisconsin and from North Carolina here tonight. It's not happening. I want to present to you tonight an overview of the new book that we've written. It was published in April of this year, published by Mountain Press up in Missoula, Montana. And it's one of a series that I'll tell you here about in just a moment. And if we can get the, okay, here we go. Okay, there we go. Geology Underfoot, Southern California. This is the second edition. I want right at the outset, do not confuse this book, Geology Underfoot in Southern California, with a previous book that Libby and I wrote, Roadside Geology of Southern California. The first book here, Roadside, says, here are the kinds of things you'll see when you drive down California highways at 65 miles an hour and you look off the side and you say, oh, I wonder what they're mining over there. Or, oh, why is that mountain red? Or I wonder what those white rocks are over there. Geology Underfoot says, get out of your car and put that geology under your feet and walk around and have a look at it. And here, this kind of thing, you can maybe take an afternoon drive or a day-long drive and go see some of this geology, or you can make some of these trips a 2-day overnighter. Let me introduce the authors to you. Mike has introduced me to you. Alan Glazner is a professor emeritus at the University of North Carolina in Chapel Hill. He has somehow found a way to make his way out here to California frequently to become one of the real experts in the geology of the Sierra Nevada and the geology of the Mojave Desert. Our author, Bob Sharp, is a professor at Caltech, a professor of geology. He passed away a number of years ago, and but we want him on as an author on this book, so Alan will tell you more about him in just a few moments. And then neither of these two books would be possible at all without Libby Gans. She is the illustrator, and if the illustration had been left to me, these books never would have been written. So a big thank you to Libby, and we'll be hearing from her in just a few minutes too. Geology Underfoot came out in its first edition in 1993, and it was all in black and white, and we have now updated it, put everything into color, and made it into this second edition. It is one of a series of Geology Underfoot books. And Alan, would you speak right now to how this series came about and your interactions with Bob Sharp and why we wanted to retain him as an author?
Sure. I learned, I was an undergraduate at Pomona College in the 1970s in Southern California, and I learned an awful lot of what I knew about the geology of the Mojave Desert, which was my first love, from Bob Sharp's Roadside Geology of Southern California, which was a book published in 1972. It was just a thin little book, but my girlfriend at the time, now wife, would read parts of it to me as we were driving around, and I would read it. He was driving. And I learned an awful lot about the area from that, but that book didn't cover anything along Interstate 40, which was where a lot of my dissertation research at UCLA took place. And so UCLA had a tradition of student-led field trips. And in 1980, my office mate, Bruce Bilodeau, and I wrote a guidebook to the Mojave Desert for a 3-day department field trip and produced a guidebook. And I found in my files a letter from 1987 when I wrote to Bob Sharp, who was 76 years old at the time. I think I was about 32, and said, hey, if you ever update that book, maybe you could put something in about Interstate 40. Here's some information. And he said, oh, I don't want to do that kind of book where you just drive by anymore. I want to do a new kind of book where people drive somewhere, get out of their cars, and look at what's under their feet. And that's how this series was born. And he took me on kind of sight unseen as an author, and we produced that first book there. And it's become a pretty successful series for Mountain Press, I think, with, I don't know, maybe a dozen, 15 titles or so. I did another book with Bob, which you can see on the screen here, Geology Underfoot in Death Valley and Owens Valley, and that will be due for an update next year. And I've done one other by myself, Geology Underfoot in Yosemite National Park, which was the first color book in the series. And if you were to compare the book we're talking about tonight to the original edition with its black and white muddy photographs and black and white line drawings, it's a whole new world.
Okay, good. Thank you, Alan. What I'd like to do next now is review some of the things we have in the book, and I'll just read a few paragraphs out of there, and we'll start with what we call vignettes. This is was coined by Bob Sharp. He said rather than have a treatise that tells you everything and then some you want to know, let's give an overview. So let me tell you about Moonstone Beach. And I'll do that by saying, well, pebble hunting is a bit like fishing. Some days are better than others, but a day spent admiring pebbles on the San Simeon coast surely doesn't count against your longevity. Just about everyone, youngsters and oldsters, girls and boys, doctors and lawyers, market speculators, sports fans and beach bums love to look for smooth, lustrous pebbles found on many mixed sand and pebble beaches. All you need is a discerning eye, protection from a cool sea breeze, and a back and legs flexible enough to allow you to pick up stones for a closer look. But beware, inspecting pebbles can be addictive. The best pebble combing beaches lie between Cambria and San Simeon State Beach. Most high tides and those associated with storms rework the beaches so that conditions change constantly. A good time to look for pebbles is after a major storm, and low tide is obviously better than a high tide. When you go out there, you're going to find these beautiful, well-worn, lustrous pebbles, about 1/4 of an inch to an inch in diameter on Moonstone Beach. Down there in the lower right corner of that picture is a picture of a seashell about 2 inches long. Give you some idea what you're looking at. The pebbles lie clustered around driftwood, large rocks, and irregular projections in the sea cliff. And an abundance of gravel may remain there for you to pick through and find pebbles. What you're mostly going to find are chert pebbles. They come in a wide range of colors, mainly reddish, brown, and green. You can assemble an amazing spectrum of shades of green, ranging from clear apple green through various gray greens and dark greens. There are many other colors, and it's just kind of a treasure and a fun thing to go looking for these. Now, a few of these pebbles are jadeite, and they are very, very hard. But the one you probably won't find at Moonstone Beach are moonstones. It's a common name for a rare pearly white semi-precious stone that belongs to the feldspar group of rock-forming minerals. It comes in many colors, but the specimens most eagerly sought after are colorless with a pearly sheen. They seem to glow in the sunshine, and even more so in the moonlight. The Romans thought moonstones were droplets from solidified rays of the moon, and today, some people regard them as a traveler's amulet for protection, especially at night. A passion stimulant, a deflector of negativity, a cure for sleeplessness, and a panacea for a host of other human ailments. But alas, you may search in vain for a true moonstone at Moonstone Beach because it's very uncommon from the rocks that these stones are derived from. But I encourage you to take a day-long trip up to Moonstone Beach and spend some time hunting for pebbles. Let's go to Guadalupe Dunes next. Guadalupe Dunes lies about 10 miles east of Santa Maria. And if you mention sand dunes, many people think of deserts. Other people have visions of seashores. Both are correct. Dunes favor those two environments because large masses of sand accumulate into dunes only where there is a constantly renewed source of sand and a strong prevailing wind that blows long enough and hard enough to move sand freely. So this is a good view of the Guadalupe Dunes looking north along the beach. I'm going to take a pointer here and show you the beach. Guadalupe Dunes rise right along here where you see the pointer, and the road comes in from Santa Maria, and you can get out here and walk along on the beach. It's a fantastic beach with hardly anybody ever there. The road goes right down to a parking lot right on the beach. It's a fantastic place to go, even just for a few hours. Let me show you what you can see once you get there. The dunes are all kinds of different shapes. They constantly move. They're being held in place by the vegetation. And you can see from the view here what a nice beach that looks like with nice waves in the background. It can also be pretty doggone stormy. Now, in 1923, Cecil B. DeMille used this Guadalupe Dunes as a set for an epic silent movie called The Ten Commandments. And at the end of the filming, his set, which was about 750 feet long and 488 feet high, was just too big to move anywhere. And he didn't want his competitors to get a hold of this set. So he had it blown up and buried in a trench 300 feet deep back there in 1923. And it remained undiscovered until 1983 when some archaeologists found it. Today, on exhibition in the museum in Guadalupe is one of these big lion's heads that you see here in the movie set. A huge big thing. There were 29 of these, and the archaeologists have managed to excavate one of these and put it on display. So I really urge you to find some time to go to Guadalupe Beach. It's one of my favorite places to visit. Next to the Kelso Dunes, and Kelso Dunes are desert dunes. And I'm going to read you out of the book here for that. Exploring sand dunes is really fun. They can be mysterious and beautiful. Many seem alive, changing shape with each shift of the wind. And the witching time for dunes is just before sunset and just after sunrise, when the shadows are long and deep, and when one may appreciate the remarkable grace of curving dune crests and the complicated intermingling of geometrical forms. You walk through those dunes at sunset when the western sky reflects its twilight glow into the sand, and that can be just a mystical, magical, almost religious experience. The best seasons to visit the dunes are winter, early spring, and late fall when it is not too hot. Now, the Kelso Dunes aren't the highest or the most extensive in the California desert, but they are among the most spectacular. They have been closed off to road vehicles since 1973, so they're relatively protected from the kind of damage that has reduced some of California's other dunes to barren piles of sand. Well, the Kelso Dunes goes on to tell you the kinds of dune forms that are there, how sand moves, how the wind blows it, tells you the different kinds of sand dunes, tells you the different kinds of critters that you might find out there in the sand dunes. Where does the sand come from? How does it move into that part of the desert, and how does it accumulate in the desert? It'll also tell you how old these dunes are And that might be a surprising thing for you to discover on your own when you go out there, is to learn how old these sand dunes might be. Well, then this is one of my favorite places to visit, the Amboy and Pisgah craters out in the Mojave Desert. We'd like to know how and why volcanoes erupt, exactly where and when they do. It's not always clear, and though a few can be tied directly to a fault or other geologic structure that might localize the eruption. For example, subduction-related volcanoes, such as those in the Cascades of Oregon and Washington, occupy specific predictable positions relative to the continental margin. But a subduction zone does not lie underneath the 30 or so relatively young volcanoes that dot the triangular region of the Mojave Desert between Barstow, Baker, and 29 Palms. Amboy and Pisgah craters are among the youngest and most easily explored of these volcanoes. Both have small craters at their summits, but mainly they are excellent examples of cinder cones. So let's look at these a little bit here. Here's Amboy Crater. You can get out there by taking old Highway 66 and parking along the highway out about over in here, walking across the desert about a mile around the side of the volcano, and then you can take a trail that goes up into the crater. You can take a trail that goes up the side and walk around the rim of the crater like this, and come down and get into the pit of the crater, as these people are doing over here. They're going down a trail down into the bottom of the crater. When you get in the bottom of the crater, you'll see a couple walls of cinders here that represent some of the latest eruptive activity in that crater. And you'll also see an ammonite down here in the bottom of the crater, a fossil. If you go over to Pisgah Crater, you'll see some absolutely classic lava flow structures such as Pohoihoi lava. And there are a lot of lava tubes in the Pisgah Crater area that have been explored and tagged by the various cave explorers in the region. Santa Barbara Harbor is one of the geological boondoggles along our California coast. The longshore drift used to carry the sand down past where the harbor is now and Stearns Wharf, and carry it on down to Ventura. And then Max Fleischmann decided he wanted to have a harbor near his home and not have to put it out in Goleta, where a natural harbor might be. So he put up the money to build breakwater. The sand quickly came in here and started filling in. And so he put up some money to build another breakwater across here. And then you can see in 1931, already the sand is beginning to accumulate up drift here of the main harbor. Here in 1964, it's spilled around the end. It's filled in this area here. And even today, then, you can see all this sand that is accumulated behind the harbor. And all the buildings and parking lots are built on that sand that has come in here just since 1929. Even LaPlaya Stadium up here is new since 1929, 1931, all built on sand that was trapped in here because of the building of this harbor out here. Well, you say, well, so what's so wrong about that? We have a nice harbor. But what I've learned even just today was that we need a dredge to dredge that harbor, and that costs us from $6 million to $10 million a year to run that dredge just to keep that harbor channel clear. Now, I said that I could not have put these books together at all without Libby's help, and I've asked Libby to comment here on her role in making these maps and how she feels that they contribute to the book. Libby, you're on.
Hello, everybody. I'm very happy to be here tonight. Yeah, it's a great honor to have worked with Art on both of the books that we've published at this point together. As you mentioned, the Roadside Geology book, but now this one too. This book, as Alan indicated, has a great history to it, and having Bob Sharp have been involved, and the fact that Alan worked on this with so much of his own personal history. It's really an honor to have been part of this new second edition. So, the maps for this book, I wanted to honor the stylistically in some ways. I know that sounds kind of funny. Alan mentioned the line drawings of the original book, but the goal was to not detract from the point of, the maps are meant to, and illustrations are meant to complement the text, and that's certainly what we went for. So I wanted to still convey the main point that the maps were to convey, but do it beautifully. And in my personal view, I think kind of seeing the natural landforms and topography of any area is intrinsically beautiful. And so I wanted to bring that into these maps, and it helps convey much of the information that we're trying to share with you. I mean, most of these maps largely are sort of location maps. But we do label some of the key points that we want the reader to be able to sort of take in and be learning about. So that was my main goal, was to find a beautiful base map that would sort of highlight the text and highlight the geology, and really the really wonderful work that's been done first by Alan and Bob, and then again by Art. So it's been great, and I think that I was really pleased with how the maps for this book turned out, and I think we were successful in creating maps and graphics that really complemented the text.
All right, thank you, Libby. You viewers out there can see the map up here on the left, and it shows the distribution of the 21 vignettes that are written up in this book, starting down here on the San Diego coast with the San Onofre nuclear power station, and what a hazard that might be, and how you can go see the geology and the fault that all people for a long time thought was going to threaten the lifetime of that nuclear power station. We go all the way up here to the Cambria coast for the Moonstone Beach. We go all the way down here towards San Diego to the Torrey Pines Beach, which is a fantastic cliff of fabulous geology to see, and then out to the eastern Mojave Desert to Mitchell Caverns. So you can see the distribution then of all these different vignettes waiting for you to discover and explore. The map down here on the right is a location map for Morro Rock location. Morro Rock is located up here in the upper right corner of that map. The story there is it's not just Morro Rock all by itself, but there are 13 more volcanic rocks that stretch all the way from Morro Bay all the way down to San Luis Obispo. Let me tell you a little bit about those, and we'll go into another slide for that. This is a view of Morro Rock that I bet few of you have ever seen. It's an aerial photo looking towards San Luis Obispo from the air, taken by our local photographer, John Wiley. I think everyone who visits Morro Bay remembers the view of Morro Rock as an isolated knob rising steeply to a rounded top, 581 feet above the sea. Describing this rock in 1769, Juan Crespi saw a great rock in the form of a round morro, a promontory or a nose, which at high tide is isolated and separated from the coast by little less than a gunshot. Well, this high dome looks so unusual that we may wonder, what is it and how did it form? Was it pushed up from below by some jolly subterranean giant just to befuddle people? Or is it simply a mass of hard and tough rock that resisted weathering and erosion, and whose durable rock on all sides has been eroded away? How can we explain its shape and its setting and its origin? And we give you some hypotheses in the book. Oh, maybe some cataclysmic force rolled it off the mountains, or an earthquake pushed it up, or it's an ancient inactive volcano, or it's just merely an erosional remnant of a once larger mass of hard rock. Well, it turns out that Morro Rock is the stump of an ancient volcano, and so are these others on down the way that you can see down off here in the distance in this photograph, going all the way to San Luis Obispo. These volcanoes erupted about 28 million years ago, and would have been quite a sight to see in their day. They would have been putting out ash all over the countryside, which is now found as sediments in the local sedimentary rock section. There are several of these, as I mentioned. You can drive on the road between the Morro Bay and San Luis Obispo, and you'll encounter Hollister Peak, which is the tallest of these volcanic stumps. It's about 1,400 feet high. There's down behind Cuesta College is Chumash Peak and Cerro Romulando. And then here's one I'm thinking you drive by every time you go up north on Highway 101, and that's Cerro San Luis Obispo, right behind Madonna Inn. I've noticed this mountain for years and years and never knew what it was until I put together this book. You can get a look at the rock itself, which is called a dacite, which is a geologist term for a volcanic rock of a particular composition. In the parking lot at Morro Bay, there's a bunch of big boulders that have rolled off down the big sea stack there, and in the parking lot, and they're nice and fresh, and you can have a look and see what the rock looks like, and we'll tell you in the book what you're actually seeing. So right now, I'm going to say thank you for joining Alan and Libby and me, and many thanks to Chaucer's Books, and turn this over to Mike, who can field the questions for us.
Okay, let's see if we have some questions here. Feel free to type in. I do have a question about how you guys produce this book. How did you all work together, having to do it remotely? I mean, what were the challenges and what were the rewards of collaborating on this project too?
Alan, you take up that one.
Well, remember the first edition was done in the late 1980s by mail.
Mm-hmm.
Bob hand wrote out his parts of the manuscript and would send them to me, and I would make minor edits and send them back, and he got a secretary to type it up. I typed up my own stuff, sent it to him, and he just bled all over it. He taught me how to write for the general audience. He was very good at cutting out jargon, at simplifying things, and writing in the more colloquial style. A lot of what Art read that sounded maybe a little bit old-fashioned. Those were Bob's words that we reworked a little bit and updated. So I learned a lot from that, and he sent me hand-drawn pencil drawings that I turned into the line drawings. Art and I, of course, had electronic means for doing all of this, and so we actually only got together a few times. We went to Torrey Pines together, and then we met at meetings and so forth to talk about it. But with electronic methods for doing things, it's easy. You know, it's all. I mean, and with Zoom, it's almost like being there. So we've come quite a ways in the last 30 or 40 years. Yeah. Art saw the need. I wasn't thinking of updating this, and Art saw the need for it. And we talked at a few meetings, and I agreed it was time to do it. And I was fairly adamant about keeping Bob's name on the book. I mean, it's his series, it's his legacy, and he deserves an awful lot of credit for that. For those of you that don't know, the explorer on Mars right now is climbing Mount Sharp, named after him, because he was at Caltech. He was an expert on sand dunes and geomorphology, the surface of the earth, and he was involved in the Mariner missions in the 60s and 70s when they first flew by Mars, got television pictures and saw these giant fields of sand dunes. So he did some of the really pioneering work in a large number of fields, but especially planetary geology, which he built up at Caltech. So his legacy is deep in these books, but it's all over geology. He was one of the greats of the science.
Interesting. We have one question, but I do want to add something towards Alan. And what was Bob like, to work with?
He was outwardly crusty. He would act gruff, but he was a teddy bear inside. He was a really sweet guy who had this gruff persona he would put on. He built the modern department at Caltech. He's given credit for turning Caltech into the top geochemistry planetary place on Earth and all. And he obviously had to throw his weight around to do that. They were a paleontology department when he became the head, and he saw the future and moved them in a different direction. But I thought it was a fantastic experience just because I had learned so much from him and learned, and as I say, writing for the public and for general audiences. I think he was really outstanding at that. He's written many, many books about glaciers and so on that are very readable for anyone. You don't have to be an expert. Yeah.
Well, I think the three of you honored him very well in this book. And I think I think it's something to be very much proud of. I have a question from an attendee, and it says, in what strata does sand have fossils? Are there whale fossils at Moonstone Beach? And are there marine fossils at Somis? That's a great question.
It's yours, Art.
That's pretty specific. Was part of the question, are there fossils at Somis?
Yes, marine fossils.
I believe there are, but I really can't say. I'm just going to have to take a blank on that one. As far as the fossils up at Moonstone Beach, I'm not aware of any there. And then incidentally, at the same time, we don't talk much about fossils in either of the books because the paleontologists really don't like the idea of people going out and collecting fossils and then keeping them for a while and then throwing them away. Fossils are just kind of one of a kind, and the paleontologists would like us not to mention much about them, and so we haven't. I know of one place up in the Eastern California where the Forest Service put up a sign and said, hey, people come on out and collect these fossils. One guy went up there one night with dynamite in a truck and blew the whole thing up and hauled it all off in his truck. And there are no more fossils there for people to collect anymore. So I'm not a paleontologist, and I am not trying to downplay paleontology whatsoever, but I think that the less I know maybe about fossils, perhaps the better.
We mentioned a few examples in the book, though. The Torrey Pines are some good fossils in the cliffs there. There's some spectacular fusilinids and so on at Mitchell Caverns. So there are some mentions in the book in some of the vignettes.
Well, that's right. And Red Rock Canyon is one of the famous places in the world where Miocene fossils have collected, and now they've been put on display in the La Brea Tar Pits Museum. So that is one place, and they have a visitor center there at Red Rock Canyon, which is pictured behind me here. They have a visitor center there with some of the fossils on display. So
and Rainbow Basin, there are a lot of vignettes that introduce fossils, but specific to Santa Barbara, I'm not sure. That's Art's backyard.
Yeah, and we don't tell you specifically where to go dig them up either.
I don't blame you. I liked how you mentioned Santa Barbara Harbor, and behind it, how Fleischmann wanted his own little harbor, and that's what happens. And now in years, we're spending millions of dollars having to dredge Santa Barbara Harbor because the sand keeps building up. We were trying to go against nature, essentially. Money was trying to go against nature. And you'd mentioned LaPlaya Stadium, and a viewer here wanted to know, how precarious is it to have LaPlaya Stadium on a bed of sand?
I think it's okay as long as that sand is well compacted and is not full of water.
Well, I'm just thinking of the liquefaction during the 87 earthquake, the Marina District in San Francisco. I think that there is water there. The ocean is right there. I suspect that will liquefy pretty pretty badly. Did we in the book make an estimate of the value of that land?
No, we never did.
I
No,
wonder what it is, per acre. Yeah.
I don't know. But the San Francisco example has a lot of mud in it, and it's made land. Well, this sand here has been made too, but naturally by nature. So maybe it's a little better compacted and makes a better foundation.
We'll find out.
That's interesting. And you had mentioned Guadalupe and Cecil B. DeMille's Ten Commandments set, and how you said it's buried hundreds of feet underground, correct?
He put it into a trench 300 feet deep,
Okay.
and then covered it over. So that maybe the top of it would have ended up being perhaps 100 feet beneath the surface. And then subsequently, over the next 50 years, the winds have blown and shifted the sand around, uncovering it all to a point where maybe a little bit stuck out, and the archaeologist came along at the right time and said, hey, look, here's a piece of plaster of Paris. Let's dig and see what we can find.
Interesting. How much damage did that do to the environment by them doing that?
Well, that's what the nice thing is about sand dunes. They can repair themselves over time.
Okay.
And that's particularly true out in the deserts today when these off-road vehicles motor all over the sand dunes. And maybe a few storms later, you never knew they were there.
Mm-hmm. My question to each of you is, what is the most fascinating geological area in Southern California to you personally?
Oh, that's a good one.
Um,
That's like, which child do you love best?
Well, I think there's 21 of them here, Mike, and we've written up about them. I will say that I have used in my teaching the volcanoes out there in the Mojave Desert about 50 times. So I've been out there that often. I know them well. I love to go out there. And so I could probably list that as one of my favorite places to go.
I would probably say of the vignettes here, I'd list Rainbow Basin and Owl Canyon. That's a little known wonder that's just right outside of Barstow. That's really worth a visit and a hike.
And it's funny, I think it sounds like we all kind of love the same area, which I think is pretty interesting given, Art and I live in Santa Barbara, which is regarded as one of the most lovely places, and it is a lovely place, but I have to say that I love Kelso Dunes and the Granite Mountains and the Mojave, the Eastern Preserve, the New York Mountains. They're just spectacular places to be. We spent quite a lot of time out there, and it's just fantastically lovely. And one of the things that I love about it is that, it's kind of like the paleontology thing. I shouldn't even be telling you how nice it is, because what I love is no one's there. Because it's just so beautiful and serene and gorgeous. And part of that's because it's just so quiet and so few people go. So it's lovely.
And you like to keep it that way, I'm pretty sure.
Just forget I said that. I didn't say that.
We'll try to flip that part out then.
Okay.
Okay, I have a question from an attendee, and they wanted to know, how much erosion are we seeing along the Southern California coast due to climate change? Are there residential areas that are threatened in the near future?
Well, the answer to your last question is yes, there are residential areas that are threatened, and you can see that along the Isla Vista cliffs today. I don't think anybody can tell you how much has happened in how many years, except by taking the rates of erosion we see today and extrapolating them backwards. So at the cliffs at UCSB, we see the cliffs retreating there. Well, let me put it this way. The U.S. Geological Survey has figured out that the California cliffs are eroding at the rate of a foot per year. 1 foot a year. Now, not nice and equally along that. Some places it'll erode 10 feet all at once and may not erode again for, say, 100 years. But the average rate over the whole California coast is a foot a year.
California coast is quite different from the East Coast, though. The East Coast, everything is flat. So rising sea level, and sea level is rising, when it's rising across something with a slope of 1/10 of a degree. See, the shoreline changes a lot. California, so much of what's going on is controlled by tectonics because of the active faults. So you have big sea cliffs and so on that are being pounded by the waves because the coast is being lifted up by faulting and folding and so forth. We have a really great vignette in here about the Ventura anticline, which is the focus of a lot of oil production, and just how rapidly those rocks have been folded like this. I mean, it's unbelievably fast. Like, you can't believe it when you see the numbers. So California's got all of that going on top of everything else related to climate.
Interesting. Okay, I have another question. What is the geology cap where the oil rigs are in the channel?
Is the cap? It's got to be a shale or a mudstone of some sort that's capping the oil in the sandstone beneath. In the onshore oil field, it is a shale, several hundred feet thick, so it acts as a seal over the very porous sandstone beds. And the geology out in the channel is very much the same as that.
Interesting. I have a follow-up, Alan, since you're on the East Coast, the erosion question. Like, how is that affecting, the climate change affecting places like where you are, like Cape Hatteras and other shorelines around North Carolina, South Carolina, that part of the Atlantic area?
Well, Hatteras and Ocracoke and all the beautiful barrier islands are basically underwater sand dunes that stick up a little bit. They're loose piles of sand that are made to move as sea level changes. And so as sea level rises, they will migrate landward, westward, let's say. But if there's hard structure on there, like roads and resorts and buildings and so forth, then people don't like that. And so they try to harden the coast, and they do things like what was done at Santa Barbara Harbor. They put breakwaters out and so on to trap sand, and that starves sand downstream and all. So it's a real mess. And barrier islands are very dynamic themselves. I have a guidebook, the cover of which shows an apartment building on one of the barrier islands with the end of the building falling into the water, and steps that go down and are just chopped off because erosion had cut back into that. And I took a field trip there some years ago, and there was a half a mile of sand in front of that place. That's how rapidly the sand moves around out there. So like everything, it's complicated, but over the long term, the barrier islands and the beaches are wanting to move, but the people who live there don't want the shoreline to move. So it's a conflict.
Sounds like it.
Yeah.
John had a comment here. Maybe you can expand on atmospheric river storms, which erode cliffs, are likely to be increasing with climate change. Anybody care to expand on that?
Repeat the question. I was doing something I shouldn't have been doing.
Okay. Atmospheric river storms, which erode cliffs, are likely to be increasing with climate change.
Yes, and so also will the coastal erosion increase, just because the sea is able to, the seas are larger in those terms. The sea is able to get up higher onshore and inshore and batter those cliffs even more. So I think that we're going to see increased erosion with these increasingly severe atmospheric storms that are coming in. I've got a couple slides someday that maybe I'll do another one for you here, Mike, that shows it very dramatically how this beach sand, when you get a wide beach, it protects those cliffs. But once you erode that sand away, the cliffs are laid bare and they can be battered by the sea. And out at Isla Vista have been ever since 1983, when a Nell came in and took out all the sand.
Wow, interesting. Okay, in closing, did each person want to add something about the project, what they came away with from working on this project together.
I really enjoyed working with Art and Libby, and if we had time, we could, Libby showed that map that had the dots for the vignettes in this book. We could easily write 2 or 3 more books filling in between those dots, because this was just a small sampling of the geologic wonders of Southern California. But I just encourage anybody who hasn't used the book, it's really written at a level that you don't need any geologic background to use. And it does make for good day trips and half-day trips and so on. And I hope people will use it that way.
I guess what I would say is that I learned a lot. I learned a lot about places I'd never been. Before this book, I'd never been to Guadalupe Dunes, and I've lived here 52 years and never been out there. Same with Moonstone Beach. I'd never been there before. Aliso Beach down by Laguna. I'd never been there. So I've learned a lot about Southern California geology, even in spite of having written another book called Roadside Geology of Southern California. I ended up driving about 6,000 miles for this book, trying to get some new pictures and getting to know the areas.
Yeah, and I guess I'll third that. It's a real pleasure working on this book with Alan and with Art, and Art and I seem to have a pretty good system for working on books like this. It includes about 10,000 emails, but yeah, it's just so much fun working on the maps and imagining. I mean, of course we've got the pictures, and I have gone to many of these locations, but when I work on one of these maps, I just become fully immersed in kind of representing what's interesting in a beautiful way. And you can be transported by, you can put yourself in that space by looking at the map and imagining yourself there. And so, and I love that about working on maps, and geologic maps in particular.
Well, thank you, you three, Alan, Art, Libby. This is really a wonderful evening. And if anybody's missed this, please, we're going to have a link for this recording. Please buy Geology Underfoot in Southern California, 2nd edition. And everybody, please don't forget to vote. Have a nice evening. Thank you.
Thank you, Mike.
Thanks, Mike.
Good night.
Good night.
I guess we 3 are here.
Yes, we are.
How are you doing, Art?
Well, I have to say no better, no worse.
Hey guys, just want you to know that it still says 14 participants.
Let's get off.
Okay.
Get off.
Well, they can join us too, but yeah.
I don't know, I can't hear them, but they'll be there, just so you know.
Okay. Well, I guess we better get off of here completely.
Yeah.
We'll sign off.
We'll talk, maybe talk tomorrow.
Okay.
Okay.
Good night, guys.
Okay. Bye.
Thanks, Lily.